Chapter 18.2, Series and Parallel Circuits. This will be at least a two-part series. A series is a circuit or a portion of a circuit that has a single path for electrons to follow and has multiple resistors. So the big thing here is a single path. And if we were to compare this to something like the World Series, in order to get through game one, in order to get to game two, you must go through game one. And to go through the series, you have to go through each of the games until you reach the end. So that's you can't skip from game one to game three. You just aren't allowed to. You have to go game one, game two, game three, game four, game five, maybe 6 and 7. But the big idea is there's a single path for the electrons to follow, and it has multiple resistors. So this is a portion of a series circuit. One thing, an entire circuit can be series, which is what this section was going to focus on, is just the entire circuit being a series circuit. Or one portion of the circuit can be in series. So this could be a portion of a larger circuit. Let's talk about resistance. The total resistance of a series can be found by adding up the individual resistance of each portion. So here's an equation. This is our first rule for series circuits. Equivalent resistance is equal to resistor 1 plus resistor 2 plus resistor 3 ... Because you could have 20 and you just keep adding them up. So looking at our example, 5 ohms, 6 ohms, and 1 ohm, if we add those up, 5 plus 6 plus 1 equals 12 ohms. There's our equivalent resistance for this here circuit. So this is our first rule. Equivalent resistance meaning if you were to consider this to be one resistor, it would be the equivalent of a 12 ohm resistor. With an equivalent resistance of 12 ohms and a voltage of 12 volts, what is the total current for the circuit? So I equals V over R. You're going to need to know your Ohm's law very well because you're going to use it so much. So I equals V over R, 12 volts over 12 ohms. That gives us a current of 1 amp. So looking now at how this works. If we were to compare our circuit, give me the pointer. If we were to compare our circuit to a hallway in the school, would each student in the class have to walk through all 3 resistors on the way somewhere? So if we were going to the library in school, we would all have to, if there was some sort of resistance in the way, we'd all have to go through it. There's no other choice, which means that the current, the total current, which is 1 amp, is equal to the current through each resistor. Each resistor gets 1 amp, 1 amp, and 1 amp. So what's the current through this one? 1 amp. There's our second rule. In a series, the total current is equal to all of the different individual currents. Now let's talk about voltage. Remember that voltage is a difference in electrical potential. That means from one point to another, there's a change in potential. From one end of the battery to the other is 12 volts. Each resistor will have a portion of that 12 volts. Let's make a comparison to our home. If you're running the dishwasher, the clothes washer, the shower, and you flush the toilet, and you got the sprinkler running in the yard, and you go to get a glass of water, is your pressure going to be cut down? The answer is yes. That's because the total pressure in your house is a certain amount of water pressure you get, and you're using all these different appliances with it. It's going to cut down on the pressure. Well, the same thing here. If we think of voltage as electrical pressure, it pushes the electrons through, the more appliances you put on there, the less pressure you get. Therefore, the total voltage is equal to the sum of the voltages on the different resistors. So the voltage through here plus the voltage through there plus the voltage through there is going to equal the total. Now, a thing to pay attention to is the fact that they're not going to share evenly. This one has the most resistance. It's going to take the most pressure. So if we were to calculate I equals V over, or V equals IR, and I was 1 amp, so 5 ohms times 1 amp would be 5 volts, and 6 ohms times 1 amp would be 6 volts, and 1 times 1 is 1 volt. 5 volts, 6 volts, and 1 volt, 5, 6, and 1 add up to the 12 volts as it should. You know, if the volts were kids in the hallway, 12 will be walking in the whole circuit, but each would be at a different resistor. It's kind of the way you think that it's going to be sharing unequally here. Let's look here at let's recap our rules. For equivalent resistance is equal to the sum of all the resistors. Total voltage is equal to the sum of the voltages. And total current is equal to the current in each part of the circuit. When we talk about parallel, you're going to see similar rules, and you'll have to be able to access these very quickly. Let's talk about series, about a couple other ideas. If one resistor in the series is broken, think of lights on an old-fashioned Christmas light set. The path is broken. That means the whole set shuts down. Now nowadays we got some little fail-safes on our lights that they don't quite shut down so easy. Next, if you add more resistors, they all have to share the voltage, so the current decreases. Sorry, the more Christmas lights you put in a series, the dimmer they'll each get because they have to share the voltage. So let's look at a sample here. Find the equivalent resistance. So 4 plus 5 plus 7 plus 2. 9 and 7 makes 16 plus 2 makes 18 ohms. So 18 ohms. Find the total current. Well, if I equals V over R, so that would be 18 underneath of 9 volts, that would give me a current of 1/2 of an amp. Now note that half an amp, half an amp, half an amp, because those are all equal, and half an amp. Through each resistor would have half of an amp, because they're all equal. So if we want to then look at the voltage through each part, we take V equals I times R, kind of solve that R over there. So it'd be 4 times a half, that would be 2 volts. 2 times a half, that's 1 volt. 5 times a half, 2.5 volts. And 7 times a half would be 3.5 volts. And then when you add those up, 2.5 and 3.5 make 6, plus 2 is 8, plus 1 is 9. So that just kind of double checks and makes sure that we're all square. So let's follow this up. There is a homework assignment here in the book, page 638, 1 through 6.